Today we're going to talk about how to count atoms, Unit 1, page 15. When we count atoms, the first thing we need to worry about is the chemical symbol. The symbol of an element represents one atom of that element. Each symbol starts with a capital letter, possibly followed by a lowercase letter. The highlighting is the part that you should be filling out in your notes. So let's look at some examples of elements. B, if we look it up on the periodic table, is the element boron. Notice it's a capital B and there's no lowercase letter. But what if we see a capital B with a lowercase a? The lowercase a means that it's a different element. In this case, this is the element barium. Finally, capital H with a lowercase e is an element. That is the element helium. Notice when I write the name of the element, it does not matter if the first letter is capitalized. But when I write the symbol, it's very important that it always has a capital letter and it might also have a lowercase letter. The next rule when we're counting atoms is to deal with subscripts. Remember, the highlighting is the part you should be filling in. A subscript is a number written at the lower right corner behind the symbol of an element. If there is more than one atom of that element, then a subscript is used to indicate the number of those atoms. So for example, Cl2. Now I know it's an L because it's a lowercase letter. If it were an I would have the bars above. When we always see I's, I would know it's a Ci2. But this is not, it's L2 because the second letter is lowercase. So Cl2 tells me that I have 2 chlorines. P4 tells me I have 4 atoms, each atom being phosphorus. H2SO4 has lots of different elements, which is okay. Every capital letter is a new element, so what we can see is that there are 2 of the hydrogen. Now SO, be careful, both capital letters. That must mean that each one of those is a different element. So the S doesn't have a number. If there's no number, the number is secretly a 1. So we have 1 sulfur. The 4 applies only to the letter, the capital letter directly before it. So that means there are 4 oxygens. So this chemical has a total of 7 atoms comprised of 3 different elements. Our next rule is what happens if we have brackets or parentheses. Well, a subscript outside a bracket or parentheses multiplies all of the elements that are inside the brackets. So for example, this 3 here is not inside brackets, so it just follows the rule we already learned, which is that it just applies to the element directly in front. So we have 3 of the Ca of the calcium. Now inside the brackets, we have the element P and the element O. Again, we know it's a capital P and a capital O, so they must be different elements. The P doesn't have a number, so the number must really be a 1. So we have 1 phosphorus inside the brackets, and we have 4 oxygens inside the brackets. Well, the 2 that is hiding outside of these brackets multiplies both the O and the P. It distributes into every single element. So rather than 1 phosphorus, we have 1 times 2. We have 2 of the element phosphorus. Rather than 4 oxygens, we have 4 times 2. We have 8 oxygens. So overall, here, we have 3 calciums, 2 phosphorus, and 8 oxygens. If we were to add them all up, 3 plus 2 is 5, plus 8 is 13. So this chemical has 13 different atoms, but only 3 different elements, calcium, phosphorus, and oxygen. Sometimes when we have a chemical, that chemical has a coefficient. Coefficient, just like in math class, means to multiply. So a coefficient is a number written in front of a chemical symbol, and and indicates the number of molecules or groups of atoms. So the difference between a molecule or an atom is that a molecule is composed of atoms, right? A compound and a molecule are similar words. So if I have 3 C's, that means I have 3 atoms of carbon. Those atoms are not attached to each other. So that would be 3 separate atoms or 3 groups of carbon atoms, each of which is composed of just one atom. The 2 in front of the next chemical tells me I have 2 molecules of Na2SO4. It's a molecule, not an atom, because it's a group of many atoms. So if I counted Na2SO4, I have 2 of my sodium, 1 sulfur, and 4 oxygens. That all equals 1 molecule. So because I have 2 molecules, I actually really get 4 sodiums, 2 sulfurs, and 8 oxygens. And that's because I'm using this 2 to multiply every one of these numbers. Let's look at a few more examples. When I'm looking at 2H2O, I can count the molecules of water or the atoms of water. So if I count molecules, molecules will be the coefficient 2. If I want to count the atoms, I need to count all of the subscripts and multiply those subscripts by that coefficient. So there are 2 hydrogens as a subscript, but then the coefficient of 2 gives me 2 times 2. For oxygen, I have 1 for the subscript, but a coefficient of 2, so I have to multiply everything by that coefficient. So overall, I have 2 molecules of water, 4 atoms of hydrogen, and 2 atoms of oxygen. If we look at the next chemical, I can tell how many molecules I have by the coefficient. So I have 3 molecules of sodium. If I look at the subscript, 2 sodiums will always get multiplied by the coefficient. So I will have 6 sodiums. If I look at the subscript for sulfur, it's missing. Missing means 1. So 1 times the coefficient of 3. If I look at the subscript for oxygen, I have 4 oxygens, but I have to multiply by the coefficient. So 4 times 3 is 12. So overall, here's my answers for this example. Finally, I have 4 molecules of this compound, which contains lead. Pb is lead. So I have this lead compound, 4 molecules of that. So if I look at lead, the subscript for lead is a 1. The 2 is referring to everything inside the brackets, and since the brackets are not surrounding the lead, all I have to worry about is that 1. So I have 1 atom of lead times the 4 for the coefficient. So I have 1 times 4 for lead. For nitrogen and oxygen, it's going to get a little bit more complicated because now we have a coefficient and the brackets. So if I look at nitrogen, again, that's just the capital N. It also has a coefficient of 1. So I need the coefficient, a subscript. I need the subscript of 1, but because the nitrogen is inside the brackets, I need to use that 2 to multiply the 1. But we still have our coefficient to worry about. So I also need to multiply by 4. So I have the coefficient times the number outside the parentheses times the subscript inside the parentheses. Oxygen is going to work the same way. I have a subscript of 3. It needs to be multiplied by the 2 outside the parentheses, but it also needs to be multiplied by the coefficient. So I have 2 times 3 times 4. So my totals for this compound are going to be 4 leads. 4 times 2 is 8 nitrogens. Then 4 times 3 times 2 for oxygen is 24 atoms of oxygen.